Yeah. So I know you before, right? I know you should get a
Yes.
marker higher than what you get right now.
Yeah. Yeah. Yes, I was in your year 3 Transformers. Yeah.
Yes. Yeah, I saw lots of you guys' name. I know. Oh, yeah, I know you before. And you guys all know I'm pretty. Uh, back to your original name again?
I don't know why it makes my name this every time.
Did
I mean,
someone register that name for you?
I'll change it.
Okay, you can change it.
Yeah.
So you guys had an exam this morning. I think for majority of guys, it's okay because high voltage is pretty big topic, and you guys probably covered a lot of things. And yeah, you got what you got. Some people get pretty good mark. Some people's mark have room to improve, but the class average is not bad. So another way to say it, just you guys have to be tough out for these 10 weeks. Now you only have 9 weeks. So you want to pass year 4. You want to get the first time because the last Friday going to be you guys writing the IP. You need to pass year 4 to write the IP. So you want to write the first time to pass it. Then that's it. Other than that, if you try to take easy for the online class, I can say now we still have only have 41 students. We're supposed to have 48. Some guy I don't know where they are. So each mark counts, and as usual, if you can get your average above 80, then come to the final. You don't need to be too stressed out. If you keep 70%, then the final, when you put all the topic together, you might get a little bit of stress down there. Yes, some of you have to get 95 average, like EFAN. And I know you are Asian guy, and for Asian guy, 99 is a fail, and 100% is the only mark you can pass. The final also online. Yeah, but the final gonna be taking questions from all different topic you gotta go through, and they have an exam with question from all the topics. Okay, so yes.
Uncomplicated process, Gardner's Witchcraft Museum in England sold the museum along with all Gardner's paintings to Ripley's International Entertainment. Oh my God. They were the ones who earned.
He probably talking to someone else. So Friday we just started introduce you to the automatic controls, and today we're gonna keep going on. Before I move on, did you guys have any question from Friday, or did you study anything from the online when you're getting bored doing your high voltage? No, everything's good. Do you have to memorize? No, you don't have to be memorize something. That's the good thing about the online part is all the exam is open book. Yeah, step motor I will talking about a little bit more. The online exam it's all open book, so as long as you know where the information is, like especially in my class, I told you something is important, you'll find a way to either put a tab or if you print out, you put a mark on that page, or if you didn't print out, you just have a PDF file or whatever, you can highlight whatever. So make sure when you're doing the exam, you can find the information because the worst thing is you have the information because before some student told me, yeah, I know the information is where I have lots of notes and working sheet, whatever. I just don't have enough time to find it. So that's another thing you got to be a little bit careful is you don't want to run out of the time for finding the information. Yes, we stopped at so step motor. I will tell you a little bit more when we first finish this part. We are right here, right? So that's talking about how we classify the control system. Major thing in this class, because you guys mostly came from construction side, and if you are from the industrial, you're probably going to take in the industrial year 4. So we just want you to understand the basic. So the first one is the very basic open loop control and the closed loop control. If we give you a system, you will be able to identify them. It's open loop or closed loop, or you know the major difference between there. You should be good. Okay, Hayden, you asked me a question. Point to a picture. Yes. You cannot hear anything? Can you guys hear me?
I can hear you.
Okay. Yeah, I think you might have to either restart your something, or did you? Yeah, you shouldn't be mute yourself. Check your audio setting on the bottom.
Hey, Jack.
Yes.
Sorry, yeah, there was just a picture that I just got my book, and I know you referenced that diagram in the book and said it was important, but I just was wondering if you could say the page number again, or if
Diagram in the book. Let me see.
I could be wrong. Yeah, I think it was that one. Just the basic elements of your control system. Yeah.
Oh, okay. Yeah.
Oh, I already have that all written down, I guess, actually.
Yeah. So I'm going to show you another one also talking a little bit more detail into this one.
Okay.
Yeah. Okay.
Thank you.
You're welcome. Then some others, they based on applications. Some others, they based on the process variables, signal type, information, transformer format. So it's in the industrial, people try to identify what type of control is. So you could be have let's say air condition control. It's based on application, but it could be a closed loop control, and it also could be if you identify in another one, it's an electrical or electronic control. So it's all how people try to reference to them. But for you guys, the basic is that you have to understand open loop and the closed loop control. Couldn't find the Zoom meeting. Did you guys check the home page for when you log into D2L? Yeah. Let me see how many students here. Now we have 47. Subtract me, we only have 46 students. There's still 2 people missing. I'm not sure who is those two people. Yeah, I believe you guys have those Discord, WhatsApp. You guys usually will share the link down there. And unless you are really not talking to anyone in the class. Yes, the link is on the course homepage. That's why I leave it down there. And each day we're using a different link for the class. Okay, now we have one more people in here. The industrial control, motion control, process control, that's on Friday I already showed you guys. This part is, I'm gonna stop here for a second. I'm gonna we go there a little bit later. We're gonna do something else first. So closed loop control is a big thing. So I'm trying to go through the closed loop control in a little bit more detail. We have another one running called a different program called Elements of Closed Loop Control System. So we know the closed loop control is more accurate, can control something than open loop control. You have the 4 basic elements down there. We're gonna, through this example, we're gonna take a look. So this is a basic heating system. We got a cold water coming in, then we got the hot water come out. We're using a controller to control a valve to let in a steam or heating element to go. Here is the heat exchanger tank. There's a pipe down here. They're gonna exchange the heat between this one and the domestic water. We have a temperature sensor down here. Based on this temperature sensor, the controller gonna make the decision how large this valve gonna be open to let in. So this is try to maintain the temperature when the cold water coming in, because the cold water coming in from a city, In the summer and the winter, the temperature will be different. But for the hot water to use for the building, for the industrial, we want to have set the temperature. We don't want that temperature to change. So that's why we need this automatic control system. It doesn't matter your water coming in at 5 degree or 15 degree. The output water will always be at wherever you require, maybe 50 degree or maybe 80 degree. This for closed loop control, we can control lots of different things. So this is the process. We can control pressures, water levels, motor speeds, or temperatures, or even some flood flows. Yes? So you saw this picture on the book already. And here, going through it again in more detail. So closed loop, we're talking about there are 4 major blocks, that like the one Hayden just asked me on your page down there. I think that's page. Let's say page 5, if you got the same version of book. And there's always lines. Lines is for linking the input and output signal between each different element. The arrow in here indicating the direction, the process. We use the measurement device to taking the measurement of the process. Then this information as the feedback signal gonna send to the controller. Those everything like the comparator, the arrow detector is all belong to the controller in the block diagram. Then the controller will base on arrow signal and the set point to output a control signal to the final control element. In here, they usually call the actuator. Then the actuator will making the change to the manufacturing process. So in here, a heat exchanger used to compare the block diagram. We use it to supply hot water. Talking about the cold water coming in, then you use the heat exchanger to raise the water temperature. First is the measurement device. The measurement device they call eye of the system. The measurement device is the major thing in this automatic control. It's a you have a good measurement device or sensor, your system will be more accurate. If your measurement device or your sensor is not very good at measuring it, then you cannot control your industrial process very accurately. And for the next few modules, we're going to talking about all different type of sensor in detail. The controlled variable is that's where the process is. We want to control wherever in this process, and how here is gonna be the water temperature. The controller, the new one, lots of controller use a microprocess unit or they use PLCs. So they receive the feedback signal from the sensor and go through the program or go through whatever the setting inside there to make the final decision, to make the adjustment. Actuator, they usually call the muscle, and those are mostly could be valves, because the valve is we can open them, close them, or in here, this is the valves to make changes for how much steam or heating flow we can go through the system. Other final control element or actuator could be motors, other type of relays. It does the purpose to make the adjustment to the process. Manipulate the variables that's altered by the actuator. In heat exchanger, the manipulated variable is the steam. So the valve will control how many steam can flow through the heat exchanger. Measure the variables. That's the monitor of the controlled variable. So in here is the temperature we try to measure. Feedback signal is the output of the measurement device. Set point. The set point is the prescribed value indicating the desired condition of the controlled variables. In here, the set point is the desired temperature of the water leaving the tank. So the set point is also a pretty important thing in this control loop, because whenever you have an industrial process, you always want to achieve a final goal, and how you achieve there is through the set point. Doesn't matter, you have a, let's say you have a thermostat, you can set into certain temperature, or you have a PLC program, you have to program it to achieve wherever you want from this process. The error detector is just making a compare between the set point and the feedback signal. Then from there, they will generate a signal for the controller to make the decision how they're going to adjust the control output signal. Error signal, usually in here, comparator, I know you guys are, if you come to school new after the harmonization for third year in electronics, you didn't learn we call the operational amplifier. But if you come to school before the harmonize that, usually on electronics, you're gonna learn operational amplifier. That's, you can consider this comparator as that. So based on these two inputs, they will give you output, depends on the setting of those two. Disturbance is something else, could be is something else, is extra things maybe outside the normal process that can causing the variation of this industrial process. So in here, they kind of thinking about maybe, let's say if the temperature outside dropping very dramatically, and you might getting the cold water coming at very low temperature. or somehow your pipe might be getting disturbed, and you might have some other things can causing the disturbance into the system. Or another thing I can think, what if your tank have a leaking, or your steam supply pipe have a leaking. All those things, it's not inside the normal process loop down here. It may changing or cause the system malfunction. Okay, so but through this one, we just try to help you to understand for this basic control, the closed loop control system, what's the main component down there, and what each those component does in the system. Okay, now we go back to so like I mentioned, some actual, like the one I just played for you, that's not in your book. That's also not in the PDF file. It's that's a separate program given to me by another instructor. He got from a certain where, and because it's a copyright material, so I cannot give that material to you, because that's what he mentioned to me. He said you can show the student in the class, but you cannot give those programs to the student. It could cause a copyright problem, because supposedly he get paid to get those programs. But mostly those programs is in addition to the book information, in addition to the PowerPoint information, you try to explain something. So usually you can find a certain information in the book, either maybe the book didn't explain very detailed. That's where, yeah. It doesn't matter. Usually I would think depends on because I know for most of you probably just have one computer. If you have 2 monitor, you have a laptop or your computer. If you play video game, you have 2 monitors. You can open the PDF file on the D2L on one monitor. You can follow me on the Zoom meeting in another monitor. I think that would be the best way, because if I told you, I said, here's the important thing, you can directly highlight or do something on your PDF file. But another way is you could, depends, right? If you have a printer or something, you want to print them out, you can also have a print out the version, go with my Zoom meeting. That way also works. So you will have your book. You might have your ink level is low. It's up to you, right? So some people when talking about this thing, if I said something is important or something, you can just write a notes or something on your paper, it will also work. Yeah, you can follow around the book also. Mostly those PowerPoint is kind of related to the book. The instructor made this PowerPoint. He took some picture from the book. It's this industrial book. But there's always a little bit of extra things here, there. Yeah, you have the if you're looking on the D2L, I'm gonna show you. So here's the D2L. Now we're still in module 1. This is the fundamental concept of automatic control system. So that's the PowerPoint. You can see we are at this page down here. So we good?
Sorry, Jack. To access that page, that's just on the Learning Hub, right?
Yes. Learning Hub. It's you go to content. So if you go to Learning Hub, you go to content, and you go to automated controls, and the module 1. The first PDF file is always the PowerPoint.
Okay.
So module 1 is down here, module 2 is down here, module 3 is down here. So always the first one.
Okay, right on. Thank you.
You're welcome. Another one I like to talking about is on the D2L. So on D2L, there is a file called a step motor type use and working principle. So step motor is one type of motor. We're using them in the industrial a lot. But for that document, I just try to explain something to you down here. I think also Lucky asked me this question. In the industrial control, we have 2 types of motor. We use them commonly. One is called a step motor. Another one called a servo motor. So the step motor is they putting type of pulse in there to the motor control part, and the motor will turn. Basically, those is for position, location. So motor will turn certain degree. Internally, they have lots of those magnetic poles. So they will energize those poles to make the motor turn to certain degree. So that will move something to a certain location. But this step motor, you put the signal in, they will move, there is no feedback. So there's no feedback to tell you how much the rotor moved. Based on their the construction down there, because they have a lot of poles, so they energize certain poles to make the rotor moves. Most commonly, those step motor, they might be moved 1 or 2 step or a few step more, or they could be moved 1 or 2 or few step less. So the difference between this step motor and the servo motor is the servo motor have a feedback. They have a certain type of electronic component on there. They can make sure if you want to, the motor, let's say you want the rotor to turn about 30 degrees, there is a feedback to tell the controller, okay, the rotor is moved 30 degree or not. But if you're using a step motor is it does not have the feedback control. There are no position sensor or whatever. So step motor is an open loop. Servo motor is a closed loop. What type of video Milan, you upload down there? Yeah, step motor does not have feedback, and the servo motor have the feedback. So the step motor is an open loop control, and the servo motor is a closed loop control. So that's the basic difference between step motor and servo motor. So here's the important thing. They put that one down there is for you guys to take a look or whatever. But yes. So you need to know what's the basic difference between step motor and the servo motor. Which one is closed loop control? Which one is open loop control? So when I say something important to know, or you need to know, you better write it down, or you better remember it. Those are not in this book, but they give you something on the D2L to show you how they works. But I told you the basic you need to know. That's good enough. Okay. The following something there. So for the people working in this automatic control industrial, they have a certain terminology, a certain drawing, a certain system it's a standardized system. So whenever people talking to each other or they working together, they have a way to communicating with each other to be able to know, especially the engineer. It's not the PDF for step motor and the servo motor. On the D2L, there's just a PDF file for step motor type, use, and working principle. So that's only one file. And I told you what you need to know is just which one is a closed loop, which one is open loop. So if you come to my class, you probably can skip that document. You don't have to read it. It's you know, as an instructor down here, because you cannot guarantee the student always listen to you. You cannot guarantee the student will always come to your class, right? But if you ask a question on the exam and the student, some student will say, "Oh, you never taught us that," then I can point out to you. I said, "Hey, here's the document on the D2L. If you don't come to my class, you can read everything down there." Even for my last class, I was taught emergency power. And after the exam, some students send me emails saying, "Hey, Jack, you never taught us this on the why those type of question on the exam." And luckily, that time, some students, they said the internet was broken. So they want me to recording that session of the class. I recorded. So I go through my lesson on the video. I wrote it back to them. I said, 42 minute, 35 second, I'm talking about this. Another point is at 55 minute, 10 second, I also talking about this. So don't say I didn't taught you in the class. Sorry, sometimes those topic is a little bit boring, so hard to keep you guys all wake up. Okay, so there is a International Society of the Automation. They have a standard called the Instrumentation Symbol and Identification. This document is uploaded on the D2L. And do you need to read the whole document? I will say it's up to you. The basic thing is already in your book. Your book covered some basic stuff down here. And for you to do the exam, as long as you have those basic things, you should be good enough. So they're talking about those. Here is sometimes called the piping and the instrumentation drawing, sometimes called the process and the instrumentation diagram. So this PID have different names, but it doesn't matter. They mean the same thing. So it's a drawing, a diagram, try to show you how a process going to be. They're using special symbols down there. They're using letters. They're using numbers, and they're using different type of lines down there. And they have special meanings, right? For that document, they will give you the total meaning. But do you really want to read that, I think 100 page or more than 100 page of document? Probably not. The document, if you're thinking about later on, you want to become an industrial electrician, you might want to keep a copy of the document, or later on you can download, find that document on the internet. But in here, we're just gonna show you some basic things down here. To explain some basic things, I have one thing is you have them in the book. So Appendix A, B, C is a document down there. I also have those interactive programs. I can use them to show you. Do you need to know the basic of the size? I put this way. So when you're doing the exam, right? You will have this book. It's an open book exam. That's the good thing. When you go to the school, you probably have to do closed book exam. Here's a bunch of symbols. Here's a bunch of what's the letter means. Here's what's those line means. You will be tested on it. That's for sure. That will be, I believe you're gonna get about 3 or 4 questions. Ask you. It's come from a question bank, so you might get asked 3 different questions that other people get asked. So some will ask you what the symbol means. Some will ask you what's the letter in there means. Some will ask you what's the number in there means. Or some will ask you what this line is. All different type of questions for different people. But if you have this appendix down here, you will be able to answer them. So I'm going to show you some basic things because I could, as an instructor, I don't want to be those type of guy. I just say, yeah, for the exam, you have these 3 appendix, good enough. That's it. Let's go home. No, I still want to explain to you, want to give you certain things. So that's why I'm going to go through those things to give you a more interactive learning experience. In the process or PID diagram, you will have those symbols on there. They usually have letters, they usually have numbers, and they call the balloons. They usually is indicating an instrument. Some of the balloon will have lines inside. The line is try to indicating the instrument location and the functions. So you will have that on your book. It's also tell you certain things down there. If you just have a balloon by itself, it's a discrete instrument. If you have a transmitter, sensor, or alarm, that would be basically a simple circle or balloon. If the balloon is inside a square, that will be a shared device. So you want to ask me what's a shared device? This means that this sensor not only going to measure something, but they also have display or controls. So you can see down here, this one is a flow meter. It will sensoring how much liquid the flow or gas is flowing through the pipe, but also you have a display on here. It will shows the flow rate of this measurement. So that if a hexagon is used instead of balloon, then a computer function or sometime it's a microprocessor. If there's a dime inside a square, that's gonna be a PLC, so programmable logical control. I gave you a picture of the PLCs. You guys gonna learn that in next 2 weeks. Horizontal line runs through the symbol. They will tell you how the instrument is mounted or where it is located. if there's no line in the center, this device or this equipment is mounted at the point of measurement, or it's near the final control element. If you have a single line in between, that means this instrument is mounted at the panel board in the control room. So it's accessible to operator. So it's usually in the control room for operator, easy to get access to them. If they have a double lines inside, that means this instrument is located at an auxiliary location away from the process. So they could be mounted inside a big control panel or wherever. If you have a dotted line inside, or they call the dashed line, that means this instrument or this equipment is mounted behind the panel, is not easily accessible. So those are the symbols and the meanings for those. If you're looking on your book, I think in my book is on page 1-17, module 1. If you got a different year or version of book, you might have a slightly different numbers. But you can see here, they give you this, all the detail in there. So now you can open the book to that page. Can you answer these questions? Oh, some of you pretty quick. Yeah, D is the correct answer. So which symbol indicating the instrument is field mounted? A is the right answer. Which symbol indicating the instrument is mounted at an auxiliary location? C, good. So if you might be seeing those type of questions on your exam, if you have the book, will you be able to answer them? Yeah, so I hope so, right? So this one is you can't do it, so I have to do it. Why make a weird noise? On my book is on page 1-17. Yeah, module 1. Yes. Did you find that? So we don't really need to do this. So that's one of them. That's talking about the symbols. Not gonna be 20 questions. You're probably gonna answer about three questions minimum for this one. Okay, Now we look at the tag numbers. Letter and the numbers are placed inside the PID symbols. They call the tag number. Those letter and the numbers provide with user the function. The letter called the function identifier are located on the top portion of the symbol. So the top is using letter to identify the function. The sequence of the letter, it tells you the instrument function. So the first letter usually tell you what type of a process variable the instrument is for. You can use pressure, temperature, flow, level. That's on Appendix B. That's the identification letter. When a symbol contains two letters, the first letter indicating the function of the instrument, the second letter identify a different means. Maybe the second letter down here, if it's a T, is a transmitter, or if R could be a recorder, could be a controller. You guys can see this in your Appendix B, page 1-18, right? If a symbol has 3 or 4 letters, the second letter usually provides information about the first letter. So in here, they give you an example. They call the PDAH. So P is for the pressure, D is the differential pressure, and A is the alarm. H means the pressure is too high. And usually the second letter, they can call it the modifier of the first letter. So that's where they call them in your book down there. The number are called the loop identifier. So the number usually is at the bottom of this balloon. A loop identifier shows the loop in which the instrument is located. So you might have a bunch of different control loop down there. And in each different loop, they will have a different name. So in here, 301 is one loop's name. You might have a different loop's name. This is the same table as what you can see Appendix B. So the first one is tell you the function. The second one, if you have more than 2, the second one may be a modifier. Then you have the next letter. If you only have 2 letters, that will be first letter down here, second letter down here. Be careful is when you have a 3 letter, that's the tricky part. The 3 letter, you might have the second letter as the modifier to the first one, or you have a first letter to indicate the function. The second letter is actually giving you on this readout or passive function. Then the last letter may be the modifier for your second letter. But you don't have to worry about that on your exam. We're not going to give you those type of questions. The user choice is if you're looking through that the document on the D2L, that's the whole document. They will tell you, or I can tell you a little bit. They will tell you the whole thing about Just give me a second. I think I have that document down here. It's at a different place where they give you the user choice. Inside the document, they will tell you, okay, what's that letter in that different location means. So second. Yeah, the user choice. Sorry, I opened the document, it disappeared. It's just based on you can looking through that the whole page of file. They will tell you if the B is in there. What's that user choice for? Just give me a second. Let me find it. Okay. Can show you this one. So in here, you can see the same table, identification letter, and they give you a bunch of user choice down here. So if you're looking through that document at above there, they will tell you this user choice for C, D, M, N, or O cover unless the repeated meaning may have one meaning as a measure or initiating variables, another as succeeding letter shall be defined only once. So N may be defined as a module or as an oscillator, something like that. And for sure, I'm not going to test you on those user choice. We just want to know the basics. Okay, so let's try some questions. So the tag number consists of both should be the right answer. The function identifier are located at which part of the PID? Top. Yeah, they indicating the function of the instrument. Milan. Okay. If a function identifier has 3 letters, the second letter B. This 3-letter one is it's really hard to see. So it depends on who's using it. Certain engineer will using one way, certain engineer, and you will have all different types. So don't worry about the 3 one. The number in the symbol indicate B. Good. Okay, we finished this one. Let's see if we have another one. You will be surprised to see how the question on your exam, or maybe even your quiz question, your quiz question sometime what's the answer for B? You mean the last one? A little bit confused on what number at the bottom. Oh, okay. So we did this. Don't need to worry about this. The number in the symbol indicating the loop where the instrument is located. So you might have a different instrument, right? You could have a complex control. You might have a, let's say, temperature sensor. You will have several temperature sensors, but depends where those number at the bottom will tell you this temperature sensor is in which control loop and where it's going to be located. Yeah, you can think about a loop as a circuit or a branch of a circuit. Now we're talking about the lines. So line is appendix C. Lines connect the symbol in the PID diagram. Here is a PID diagram. You have a bunch of C. You're probably mixing the soda ash and the phosphoric acid together to make a salt product. Each line represents the physical connection between the instrument. So in here, they tell you this is a pneumatic signal came from this is a converter, because for this process you have a control valves. Here's a air pressure regulator. This will be using air pressure to controlling the control valves open and closing. But your controller will sending an electrical signal into this. I is the current, P is the pressure. So this is a converter. They receive a current signal, then converting that current signal into pneumatic pressure. They use the air pressure to turning this control valve. So Appendix C, you can see down there if a bordered line, which means if just smaller lines and the line with the dashes, or if a dotted line, hydraulic line, software link, capillary tubes, or electromagnetic signal, or mechanical connections. So those are all different type of lines will be used in the PID drawing. And we can look at instrument supply, steam, raw material, final product. And those single line, the meter in the pipe, material passing through. Pneumatic signal, pressure the air. This is a standard. We go to second module 2. We're talking about usually the pneumatic air pressure 3 to 15 psi is the standard signal. Electronic signal usually either you can have a 4 to 20 milliamp signal, or 0 to 10 volts, or you can use some industrial standard communication signal. So hydraulic we know is a hydraulic pressure signal. This is, I believe you guys learned this in motor control a little bit. So software link is communication between computers. Mechanical is a physical connection. Like we learn in motor control, we have those mechanical links. That's it for this one. Then we have one more. Sorry, guys. What time are you guys thinking about the coffee? I know I usually said that you guys want to take a coffee or? Okay, yeah, let's take a coffee and come back at 1 o'clock. Okay, see you guys in a bit. Okay, you guys back? Okay, good. We have one more to do. So now we're talking about reading the PID diagram. Oh, I think now people said I'm improved. I'm not allowed to show the ruler anymore. Go back to the first page. Nothing on the first page. The first page just said you have to go through the one we already go through. In here, they're talking about this, providing lots of information. They tell you which component is in the circuit, how they connected, and where they located, or what's the function. So we already learned, you can see all those components belong to loop 401. So 401 is identify which loop is, where those instrument is located, and the TT or TV or TY or TIC, it tell you each instrument's function. Usually in the industrial, when you're reading this, you can understand the process or troubleshooting them. That's the main use of them. Here they're gonna show you a bunch of things, a single loop. So this is talking about this heating down here. Heat exchanger. So this is the valve. Valve is this part, is the controlling. The number 401 indicating they are located in the control loop. 401. T is measuring the temperatures, and this is temperature control loop. Second letter indicate this T is a transmitter. The balloon have no line, so it's a field mounted. The line X, this line is a capillary tube sending a signal from the exchanger to the transmitter. This dashed line is an electronic signal. So from this transmitter to the controller, gonna be an electronic signal. The controller is this part. So like this one, TIC, so it's temperature indicator and the controller. That's what when we talk about three letters, right? In this case, the I is not a modifier for the T. The I is actually the second letter is a indicator. The C is a controller. So The solid line indicates it's a ball mounted. The dashed line tell you it's a electronic signal. This one we call a transducer. The Y, the function, the Y is a converter. We're gonna converting the current signal into a pressure signal. This is the pneumatic line, so use the air pressure to control the valves. So this use a diaphragm. If you put more pressure down there, it will move these valves either up or down to controlling. Fail to close, or fail to open. It's for the safety reason. If something in this control loop, let's say the electrical signal line or air line, it become damaged, or you have a problem with that line, for this process, if this valve keep supplying the steam, will cause damage to the process, or for certain process, if you don't have the steam coming in, maybe the material here got to cool down too much. It also can cause damage to the whole process. So that's where you're gonna pick those valves, either fail to close or fail to open. It depends on the process requirement. So in here, later on we're gonna talk about more in fail to close or fail to open. Okay, maybe we stop here. This is an example down here. So if I give you this one, or give you a portion of this diagram on the exam to ask you, okay, what's this one is, what kind of line is down here, or which control loop is this located, will you be able to answer those questions? Hello? You should be able to, right? So that's what we're talking about, is this PID diagram, identification, everything. Make sure you have the book, and you have those drawings, you have those letters. So you will have a few questions on this PID diagram. We good? Yes, no? Yeah, okay. So that's module 1, and the first 2 modules, we're gonna go kind of little bit slow, because there's lots of basic thing in the first 2 modules, and the majority of your exam question came from the first 2 modules. The later module talking about individual sensory equipment or those things. it's not every module have some question, but the later module gonna be a smaller portion. The module 1 and 2 is gonna be the majority. I think maybe about you have 15 questions. The first 2 module gonna have about more than half the question came from the first 2 modules. Almost like you have a total 50 questions for the exam, and first 2 modules we have about 28, 29 questions as it came from the first 2 modules. So we're gonna go a little bit slow on them and make sure you can get them. Okay, we good? Now we go to module 2. Module 2 is talking about sensor, transducer, transmitters. First thing is these 3 words, sensors, transducers, transmitters. In the industrial, and the people sometimes using those words is interchangeably. So some people will talk about sensor, some people will say that's a transducer, some people will say that's a transmitter. But by the book's definition, they have each have a slightly distinguished characteristics come with it. Just kind of like when we in the electrical trade, on the job, you saw a white wire, you always call, oh, that's a neutral wire, right? But by the code definition, there's an identified conductor, there's a common conductor, there's a neutral conductor. That's actually a different thing in there. So we try to do here is explain them to you to make sure. Depends on the question. Sometimes it's a little bit tricky down here. Sensoring device is used to do a measurement or taking some kind of information from the process to give to the controller to make the decision. We're talking about inductive proximity sensor. Those type of sensor is for usually is measuring metal object. So if you have those, let's say you have those pop cans, like beer or Coke cans, you could use an inductive proximity sensor to detect them. Are they close by or are they not close by? But those sensors will only working on the metal objects. If you have glasses or plastic cups or paper cups, they're not going to be able to detect it. Yeah, so I think that's important to know. What type of material an inductive proximity sensor will be able to detect? Yes? No? You guys are awake? Okay. So when I say important to know, you know it's important to know, right? Magnetic proximity sensor. Those magnetic ones, they were only working on ferromagnetic material, right? So if you have iron or steel a cobalt, those kind of thing, they could be detected. But if not, if the material is not a ferromagnetic material, the magnetic sensor probably not going to pick them up. Capacitive proximity sensor, those type of capacitive one, they can detect all those. Basically, most material can be detected by the capacitive one. So it doesn't matter is it metal or non-metal, it's a ferromagnetic or non-ferromagnetic. Capacitive sensor can detect lots of different things. Photoelectrical, those are mostly is sending lights out, and they will either receive the lights from another end. Am I repeating that one? So inductive sensor, they detect all the metal object. Magnetic sensor, they detect ferromagnetic type of material. Capacitive sensor, they can detect all type of material. Almost all type. Yeah. Is that good, Hayden?
Yeah, that's perfect. Thank you. I was just having a hard time keeping up with you, but I'm there now.
Okay. Laser is also kind of sending out a laser line. Usually those is if you have anything passing the light path, you block the line, or you can reflect light back. You usually, those one have to come with a receiver to working together. What's a ferromagnetic? That's when you're learning first year. You learned iron is ferromagnetic. Steel, like you have soft iron, you have hard iron. Anything contain iron in there, usually consider ferromagnetic material. Or if you have a cobalt or copper, that's another type of material. But mainly is anything contain iron is ferromagnetic. Yes, so if it's a metal, it's always you can use inductive. Photoelectric, they usually those one, it's always you have one is called the emitter. They will send out lights. They either give visible lights or infrared lights, and this laser also give laser lights. And you will have a receiver. So the receiver will if the lights can passing through, the receiver receiving the lights, that means nothing in the path. If the lights got blocked, or sometime they will using, depends on the subject, they will reflect the light back. So depends on where they locate the emitter and the receiver, they can detect if there's a material passing by them. Yeah, ferromagnetic material is iron. Yeah. Yeah, both of them usually contain emitter and the receiver. Sometime if you have sometime is detecting things by so I'm gonna save some paper. If you have a emitter here, you send out lights, you can have a receive down here. So if you have any material passing here, you block the lights, the receiver didn't receive the lights, they will think, okay, there is a material passing by, or either a box or whatever the material. And another type is you have a emitter here. But this emitter is putting in kind of in an angle. They will give out a light. Then you will have a receiver. Here. So here is the material passing through. When those, it depends on the application. So those one you usually have the material have a shiny reflect surface. So if when you have a piece of material passing here, the emitter send the lights will be reflect, go through to the receiver. That's where they can detect if there's a material here or not. So different application, different ways. Photocell, like you said, yeah, photocell is different thing. Photocell is to detecting if you have enough lights. That usually for those light controlled lamps, or usually for lights, if you want to turn on those nighttime lights or whatever, to use the photocell. Because the laser beam, it usually it can transfer for a long distance, and it's not the other type of lights. It will like the path will go brighter. So if you have a long distance, you use the laser. If your distance is shorter, you can just use normal lights. So they both can be used for security, but if you, let's say you have a perimeter, those emitter and the receiver, if the distance is usually longer than 10 feet, you will use lasers for security. But if you in here, we're mainly talking about in the industrial for sensoring the material. So electro sensor, and your book also gave a definition. It's a device that detects a quantity or energy that directly convert it into an electrical form. So in here, we're mainly talking about sensor, transducer, transmitter. We're talking about electrical type. The input to those sensors, it could be electromechanical type, or you can be the makeup of a different chemical. You can be temperature, pressure. There's lots of different type of sensor for each different industrial application. But for the electrical sensors, the output will always be electrical signal. In here, we could use AC or DC, either the voltage or current. And they taking whatever you try to measure or you try to monitor, when the input signal changes, we causing the output either voltage, resistance, capacitance, or current change. So they using the change of the output signal to either measure or to monitor the change of the input signals. So they give you one example down here is called a thermocouple. Another one, pressure sensor element or solar panel. Thermocouple is if you change the temperature, they will causing generate a smaller voltage down there. pressure sensor, depends on what type of pressure sensor. If we have a strain gauge, when you have the pressure on there, they will change the resistance. Solar panel, the solar panel, we don't use that for the sensor too much, but in here, if you have a light shining on the panel, they will generate a voltage. A normal electrical sensor, even they can output electrical signal down here, doesn't matter AC or DC, or voltage, resistance, or current, the signal is usually too low. So we cannot use those directly to control something. We usually have to put an amplifier to increase the signal amplitude or magnitude, then go to the control application. What's being monitored, the change in input signal? Sensor is using for monitor any type of input. So if you try to measure the temperature, you will use temperature sensor. The temperature sensor, if the temperature changes, the temperature sensor can give you a current output, a resistance output, a voltage output. Or if you want to measure pressures, the pressure will be the input to the sensor. Then the sensor's output will still be either the voltage or current or resistance. PLC usually is taken as a controller. So you will use the sensor's output, go through amplifier. If you have a simple control, you might have a simple controller. If it's a complete, very complex control, then you will put those input, go through certain type of amplifier, then converting them into as a PLC inputs. Here they talking about a piezoelectricity. So the piezo, you guys learned in year 1, I believe. There's they talking about ways to generate electricity. So the piezo is if you either give a press, you press on that, or you extend on there, you dragging or push on there. Depends on the force you apply and the magnitude of the force, the piezo material will generate a smaller voltage. Yeah, those are usually related to the pressures. So if you try to compress them, they will generate a smaller voltage. Usually, this type of material is using in the microphone, right? So when you speak, your voice, your sound gonna repelling the air, and when they touching the microphone surface, it will causing the pressure change on the microphone. Then you will converting that into an electrical signal. Photovoltaic, that's we're talking about the PV panel or the solar panel. It's whenever a solar cell, you have sun shining or light shining on the surface of the panel, they're going to generate electricity. And that's where we're going to learn in renewable energy. A different type of temperature sensor. The detail we're going to talk about in module 5. You have a thermistor, you have a resistance temperature detector. For them, it's all whenever you're either heating them up or they have a temperature changes, they will causing the resistance changes on those materials. Thermocouple is when you heat the thermocouple have a hot junction and a cold junction. They usually use two different type of metal joined together. If you heat this hot junction, they can generate a small voltage at another end. When one end is you join these two different metal together, another end is where you can measure the voltage on here. So it's also in the book, you're talking about, I think they call it active and passive transducer. So for thermocouple, because they can generate a voltage, voltage is we call the electrical motive force. So when they generate a voltage, the thermocouple is considered active transducer. But for this resistance temperature detector, when you're heating them up, they just change the resistance of these RTDs. So to measure the change of resistance, do you need either a multimeter or you have to put in a voltage source down there, so you can measure the current by giving a voltage go through there. So if the resistance changes, you will change the current. So those type of material is considered passive sensor. The yellow one they try to indicating is a copper wire. The black one or the dark blue one is another different type of metal. It depends on the temperature range you try to using and the accuracy. You will using different type of metal to make this thermocouple, because some for the low temperature measuring, some for high temperature measuring. That's how they choose different metal, but which metal to choose for that, I think we don't really care. Yeah, the hot junction is where you join that two metal together, you heat them up. Those two metal, when they're heating them up, they kind of have some kind of chemical reaction going to happen on there. So that's where the voltage is going to generate. The cold junction is usually for the, we call the temperature compensation, because when you're heating on here, you also, the cold junction is usually located slightly far away. It's in the ambient temperature. So if your ambient temperature down here is 30 degrees and your hot junction down here is maybe 100 degrees, so the difference between here will causing the 70 degree, we're causing certain type of voltage down here, instead of if you have 100 degree here, 0 degree here, then that will be a different voltage generated down here. That answer your question, Sean? The hot junction is where the voltage generated, but also depends on cold junction temperature here. They will causing the generated voltage will become different. Yeah. Yeah, if a more different voltage down here, you can have a mostly you'll have a higher voltage generated down there. But still, the voltage generated down here is in the millivolt range. So if the temperature difference between here and here, maybe let's say 200 degrees, you might have a 0.25 millivolts generate, and the temperature between here and here is 100 volts. you might have a maybe 0.15 millivolts or 115 millivolts or something. Yeah, the voltage generated, the thermocouple is generated in millivolt ranges. Very low voltage. So because that low voltage, you cannot use to driving to control anything. You always need an amplifier to increase the voltage to do something. Oh, you're welcome. It's my job. I got paid to answer those questions. Sometimes if you catch me on a question I cannot answer, I might ask you. I said, okay, let me do some research or find them. Transducer. A transducer, electrical transducer, is a device. They receive the information in one form and they convert it to another form. So a transducer is using down here. Let's say you have in here they use a thermocouple. So this thermocouple, they will generate a smaller millivolt voltage. Then you use an amplifier to increase this voltage. But they also have something called a signal conditioner or filter. They try to make that thing more useful, more stable. Then they could have an output circuit. They will output wherever that millivolts. Now you can convert to maybe different type of signal. So we could convert that into a standardized industrial signal 4 to 20 milliamps or 0 to 10 volts, or maybe because here is a voltage to current converter, so the output will be the amps, but depends on here. You could have electrical transducer. It's always converting either to the voltage or current. If you have other type of transducer, they might converting into air pressure, or they might converting into a temperature. So you could use a thermocouple down here, right? You measure the millivolts, you increase the value, use a filter, or you can put a microprocessor or display down here to actually to shows wherever the temperature is here. Yes, so the positive and negative number is showing you this is a DC current. DC current is commonly used in this type of circuit because DC current can give you not only like not only the amplitude, like we give you the number down there. It also will tell you the direction of the current flow, right? So we know if you, let's say, you can calibrate this thing. If measuring at 0 degree, you will have a positive 4 milliamps, and if your temperatures go below 0 degree, it might give you a negative current down there. So transducer, they always use an input as a sensor as the input to measure temperature, pressure, or speed, or whatever the type of the variable or the process. The output of the sensor or transducer, it can be in different forms. So it depends on the equipment, what type of the signal the equipment is going to receive. You will choose the right type of the transducer to converting that input signal to the output signal. Here is some type of the question you might see on your quizzes or you might see on your exam. So we try to make sure you understand here. So because sometimes this type of question is kind of tricky. Yeah, someone pick C. So device used to provide information on the condition of state of a process. Its sensor. Even we're talking about transducer have the function, but because these two both are here, so the right answer will be C. That makes sense? Yes, no?
Yep.
Okay. Next one, if they ask you, a transducer is usually a sensor, true or false? The answer will be true, because sensor is a type of a transducer. And also, another question is that a transducer is usually an output device. The answer also be true, because the transducer can also be an output device. So, that's where the tricky between sensor, transducer, transmitter. I hope I didn't confuse you too much. It doesn't matter, it's 51% or 49%. When they give you those type of statement, because most sensor, it try to take the input, then converting into another type of information. So you try to converting the information, that's transducer. The output device, also the transducer, basically just changing one form of information to another. So the output device is also changing the information from one type to another type. That's why you saw these two guys. I hope you are now gonna be the guy like those two, right? We have 47 students here. So I hope everyone here, you're now gonna make, if that, let's say, a possibility you encounter those type of question, you will have the right answer, not like those two guys crying. That's another reason I like this instructor's PowerPoint. Alan, his name is Alan. So we already showed you here. If you make those type of mistake, you cannot blame me. And if you come to me, you said, Jack, I don't think that's right. I will show you this. Okay, next one. That's a sad face. So the right answer will be D. So the transducer can be the output, can be the input, can be the sensor. What is this thing? I have no idea. And I don't even know where he found the picture of this thing. I think we can call this is a sad and a mad person. Transducer, yeah. Transducer, it's better. Here show you certain type of different transducer. The strain gauge is for measure the pressure. I hope you can take the information we give to you and convert to useful knowledges. The strain gauge is the sensory element. You will taking in the pressure, usually is for measuring the pressure. And the output down here, they have to give you a voltage change as the output. But the strain gauge is a passive transducer. So you need to have a voltage, a power source down here. And most commonly where you're using the strain gauge is in this type of circuit. In year 1, when you learn the DC, you have a special name for this, right? Did you guys still remember?
Bridge rectifier.
Do I have diodes or do I have resistors?
Oh shit, yeah.
It's okay. I still give you a mark because you answer my question. Otherwise, my class will be too quiet. Anyone remember the name? Emily, not? It might be when you're doing the quiz, they're talking about this one. It's called the Wheatstone Bridge. Oh my God. You guys all forgot? Yeah, that is a bridge down there. Okay, then we have a resistant temperature sensor. This is a resistant temperature detector. And also the input as a temperature and the output is also a voltage change. The resistant temperature detector is also a passive transducer. So the same thing, they need a power supply. Because the changing of those resistor depends on the pressure or the temperature is not very, we're talking about the output for those sensors is in so low level, you cannot use directly. That's why, because in the Wheatstone Bridge, the slightly change in this voltage or in this resistance down here gonna causing a pretty higher change on the voltage down here. That's how we can depends on the slightly change on the resistance down here to identify the temperature change or the strain or the pressure changes down there. The Bourdon tube, I believe you guys learned this one in motor control, I believe. Right, because it it kind of just like a device. When the pressure going to this tube, we're making this tube either coil up or expand out. And when they expand out, they have some kind of mechanical linkage to connect on a needle down here. So if we make the needle moves to indicating how much pressure in the tube down there. Usually this is for a pressure gauge to measure the pressure. Transmitter. Oh, now we finally come to the last one. A transmitter is a type of the transducer. The transducer will always have a sensor, but this one, we have additional component to make sure the output is a standardized signal. So that's in your book 2- page 2. Transmitter is a transducer. The transmitter's output is standard signal. Can you explain why the change in R is minimal? Because let's say those RTDs or the strain gauge, right? Let's take a RTD. You try to use it to measure the temperature. The temperature you can be increased in maybe 1 degree or 0.5 degree. That device, the RTD, when the temperature only change in 1 degree, maybe the resistance change in, let's say, 1 milliohms. The 1 milliohm change in resistance, you cannot even use a multimeter to measure that change. Because the changing in resistance is so small, you don't have an equipment it's accurate enough or have enough accuracy to measure that change. That's why you put in a Wheatstone bridge. When that 1 milliohm changes in that Wheatstone bridge, it can cause in maybe 0.5 volts or 1 volt in that Wheatstone bridge. Depends how the resistance bridge build up in there. That makes sense? The strain gauge is most type. You saw if you're driving on a highway, you saw those weigh station, like for big truck. Yeah, they are using those strain gauge. They put under a big piece of. They use those sensors under big piece. Usually is a metal plate. So a truck driving on top, because the weight of the truck going to press that strain gauge down. And the strain gauge, when you get pressed, it will change the resistance. So they can measure the change of the resistance to converting into how many weights on top of that. So they can take, okay, your truck is a 5 tons or 10 tons or maybe 20 tons. Yeah, either use on those weigh station or that's for the large use of them. The smaller use is like those electronic scales at your home, put you in your bathroom, right? You try to weight yourself how heavy you are. They also use some type of a strain gauge. So all the transmitter is a transducer, but not all the transducer is a transmitter. You have to have a standardized output to be considered as a transmitter. The common analog transmitter is usually we use 4 to 20 milliamps. That's the output. Some of use digital output. They will use they might use this HART. HART is a highway addressable remote transmitter, or you can use a field bus. You can use a Profit bus, process field bus. All those digital communication. The new one now even they will have the normal network like a TCP/IP protocol. They also could be used as the new one. So the difference between transducer and the transmitter is all the transmitter is belong in the transducer category. But to be qualified to call the transmitter, they have to have standardized the output signal. If they didn't output standardized output signal, you can only call them the transducer. You cannot call them the transmitter. Okay, so all the transmitter is belong into transducer category. But to be able to call that transducer a transmitter, they have to give out standard industrial standard output signal. So if a transducer, they can supply 4 to 20 milliamp or 0 to 10 volts, or those any type of a digital output signal, they could be called a transmitter. Xiangyang, you got it backwards. All the transmitter is transducer. But the transducer, one portion of the transducer gave out standardized industrial signal. This one can call the transmitter. If they don't give out standardized signal, those are just called the transducer. The whole thing here is transducer. So they take one signal, output another signal. A smaller portion in here is transmitter. They output standardized industrial signals. So maybe 4 to 20 milliamps, 0 to 10 volts, or digital communication signals. Yes, some of the transducer can be called a transmitter. Yeah, all the transmitter is transducer. Yeah, so if our transmitter can be, if our transducer can output those standard digital, let's say TCP/IP, or mostly in industrial, they use industrial network signals. Those are all transmitters. In the industrial, they use the Cat6 cable, but those cable is much stronger. They have those. They all have a shield outside. The cable is much heavier gauge. Case, what's your language in my class? The transmitter, if we say, let's say you might have hundreds, thousands of transducer, but in there, that may be tens of thousands could be a transmitter. Yeah, inside the category, that will be smaller. Case, be careful. In our class, we have we know we're all trades person, right? But still, in here is a school. We have to be careful because we have girls, we have ladies, we have people from a different culture, we have people with a different background in here. And as an instructor, I have to make sure our class is inclusive. Everyone we feel comfortable in here. So we try not to use any type of the language or anything can cause anyone feel uncomfortable in my class. So if sometime I said something improperly, you guys can remind me also. Yifan, you can only say for yourself, right? It's also another way is inside the class, I can see all of you guys' face. We're all facing each other. I will say if someone's feeling, I most time I can feel from students' face expression. I know certain thing if causing other people uncomfortable, I will stop that. But here is all online class. I cannot see you guys' face, and I don't know what you guys feeling about. So that's why in the online class, I will be more careful about those things. Yeah, so we're probably gonna stop here. We're gonna start continue tomorrow morning. If you don't have any question, you can just go to do those. There's online quizzes. Try them out, and you can read the book. Do whatever the study material you think is appropriate. If you have a question, I will